Hi, this is Varun studying in Sri Venkateswara College of Engineering ECE department. We are here to explain the solar space cooling of building. Introduction. In solar cooling systems, solar heat is used to drive the cooling process. Thermally driven cooling machines such as absorption or hard absorption chillers have been used for decades, but have been powered mainly by industrial waste and heat distinction sheet. In recent years, demonstration projects have shown on the potential to use solar thermal energy to drive those chillers. Because most of the available thermal chillers have large cooling capacities, often several hundred kilowatts, the focus R&D was largely on developing solar smaller cooling units as well as to improve the thing's design. About 100 systems have been installed in Europe and several companies are offering solar cooling solutions as part of their product service profile. Why solar cooling? A dramatic increase of air conditioning since early 80s, cost of energy, issues related to environmental pollution that are follows due to energy production due to use of CFCs and HCFCs, matches demand with core availability, crucial for improving life standards in developing countries. Solar cooling systems. In solar cooling systems, solar heat is used to drive the cooling process. Thermally driven cooling machines such as absorption, adsorption, chillers have been used for decades, but have been powered mainly by industrial waste heat or district heat. Components of solar cooling systems. A solar cooling installation consists of a typical solar thermal system made up of solar collectors, storage tank, control unit, pipes and pumps, thermal driven cooling machine, chillers. And this is the operating principle for air conditioning with heat sources. And heat passes through thermally driven process and it will continue with chilled water and conditioned air. And so solar collectors. Solar collectors are the key component of active solar heating and cooling systems. They gather the sun's energy, transform its radiation into heat, they transport that heat to a fluid, usually water or air. The solar thermal energy can be used in solar water heating systems, solar cooling systems, solar pool heaters, and solar space heating systems. And the classification that follows: flat plate collectors. Flat plate collectors are the observing surface approximately as large as the overall collector area that intercept the sun rays. And second one is concentrating collectors. Large areas of mirrors or lenses focus the sunlight onto smaller absorber. And the solar collectors, in this diagram we can see that and heat is falling on solar collector and it will join into a solar tank, storage tank. And one more is chillers. Chillers are the core of solar cooling plants. If solar panels provide necessary energy input to the plant, chillers are those machines that are able to produce cooling by utilizing the hot water coming from the solar panels. And a chiller is a machine that removes heat from a liquid via a vapor compression or absorption refrigeration cycle. And most of water is chilled, but this water may also contain 20% of glycol and corrosion inhibitors. Other fluids such as thin oils can be chilled as well. Components of adsorption refrigerator. Components of adsorption refrigerator are follows: solar collector, absorber, generator modules, etc., and condenser and evaporator. Work procedure is follows: step 1 deabsorption and drying of adsorbent, step 2 adsorption, water vapor is adsorbed at the surface of adsorbent, step 3 follows that return to the condensate. And working process of adsorption chiller. It contains water vapor, liquid processed water, check valves, condensate, return, driving heat, heat rejection, and cold generation. And remarks of this one is under typical operation conditions with a driving heat temperature of about 80 degrees Celsius, adsorption chillers can achieve COP of about 0.6, but operation is possible even at each source temperatures of approx 60 degrees Celsius. The capacity of these chillers ranges from 50 kilowatt to 500 kilowatt chilling power. And here we can see the chillers in different countries like Germany, Greece, Spain, Portugal, Italy, Austria, France, Holland, Israel, Turkey, and Serbia. Solar cooling applications follows that wine store cooling. Use cooling of wine store site when South France. Solar thermal collector field is 130 meters square evacuated tube collectors chiller adsorption chiller with 52 kilowatt cooling capacity. Air conditioning of a factory, and it used as air conditioning of production facilities in a cosmetic factory site. It is an inverter VRTS solar thermal collector field 2700 meter square flat plate collectors chillers, two adsorption chillers with 350 kilowatt each, and three compression chillers with 350 kilowatt each. Hotel air conditioning. Air conditioning of a hotel and steam supply for the hotel laundry site. It is located at Turkey. Solar thermal collector field. It has 180 meter square parabolic through collectors, aperture area, chiller, double effect adsorption chiller. It contains cooling capacity of 116 kilowatt and 4 bar. And it's the video. Thank you for watching.